Jumbo. This video is about covalent bonding. You will recall ionic bonding involves a metal getting together with a non-metal. Metals have outer electrons that they want to lose, and when they lose them, they become positive ions. Non-metals are short of having a full outer shell and want to gain electrons to have that full outer shell. And when they gain electrons, they become negative ions. And the opposite charge between the positive and negative ion holds them together, the ionic bond. Well, in this case, we are looking at covalent compounds, and they involve these elements to the right of the staircase, and they can involve hydrogen. So you have these 16 elements that we look at involved in getting together. So nonmetals are all short of a full outer shell, so they'd all like to gain electrons. But if you have two things that want to gain, you don't have that nice deal in ionic where a metal wants to lose electrons, nonmetal wants to gain. It's a perfect relationship. In this case, instead of theft, a nonmetal stealing electrons from metal, it's ooey gooey Barney world where they're going to share electrons to be in their happy place. So that's our little intro before we get to this PowerPoint. So here's the PowerPoint that you should find in your notes. It says covalent bonding. First thing is non-metal plus non-metal. So no electron transfer. This is a sharing of electrons. That means the electrons involved in the bond will spend most of their time between the two atoms. And generally they're obeying the octet rule unless they're small around helium. So we're going to do an example of fluorine, and we're not going to look at a compound. We're looking at the element, but it turns out we know fluorine is diatomic, 2 atoms in its structure. And we're going to cheat. We're going to use something called Lewis structures that comes up later on. And it makes it nice and easy for drawing. Lewis just said, hey, let's not care about the inner electrons. All that matter are the outer electrons. They're involved in bonding. And so what we've done is we've put in the 7 outer electrons in this arrangement. And we can see there's a gap here and a gap here, where both fluorines right now are very unhappy. And it means they'd want to be quite reactive. Well, the usual deal for bonding, we need the atoms approaching each other. So that's why we have those clever arrows. And then they flash for some reason. And now we change the color of them to show that they're bonding electrons. And what it says is when these get close enough, should be a cursor showing up here somewhere. Oh, not seeming to. That's that. Oh, if the cursor was working, there we are. As these atoms get closer to each other, this electron will be attracted to this nucleus and the nucleus of the other fluorine. This electron's attracted to this fluorine nucleus, but also the other one. They're going to be attracted to both nuclei when they're shared by both nuclei. So now, these electrons don't even really know which atom or element they belong to. They belong to both atoms in a sense. They're attracted to both at the same time. And that's what we talk about being shared. And often we like to draw a ring around. And if I drew, well, actually I'll try drawing a ring. That's supposed to be a ring, not a square. Okay. What you see is the bonding electrons are in the middle. They're where these overlap. And in that overlapping is where you find the bond electrons, and that's a covalent bond. Now, most elements are monatomic, made of one atom when they're in the elemental phase. But there are quite a few that consist of 2 or more. and you are expected to memorize them. Certainly if you go into Chem 12, or Chem 11 and Chem 12, you should know what they are. They're cleverly called diatomic elements because di means two. So they're elements made of two atoms. The way to remember them is by saying hal, no. Hal for halogens, all the group 7, and then nitrogen and oxygen and hydrogen. Or hydrogen. Made of two atoms, and here they are. So when this only applies when they're by themselves, not in a compound. When they're by themselves, they all have a 2 for a subscript. So make sure you remember that. Hal, no, we won't go. There are other ones. Phosphorus is actually made of 4 phosphorus atoms. That one I don't expect you to memorize. And sulfur is made of 8, a ring of 8 sulfur atoms. So here, tetratomic and octatomic. So that's it for bonding.